Okay, and finally 45 through 48. These are the race car problem. You're videotaping a race from a stand 180 feet from the track, following a car that is moving at 220 feet per second. About how fast will your camera angle be changing when the car is right in front of you? And 1.5 seconds later. So again, we draw kind of a sketch. And this is my sketch. Here's my race car. It's moving from left to right. This is x. And its velocity would be dx dt. This is the position. Sorry about that. If my dogs want to go outside, so I'm going to let them out. Okay. I can hear them barking. Okay. Anyway, so dx dt would be the velocity, and they tell us that the car is moving at 220 feet per second, so that's dx dt. So dx dt is equal to 220 feet per second. Okay, alrighty. And how fast will your camera angle be changing? So this is the camera angle. And how fast will this be changing when the car is right in front of you? And 1.5 seconds later. So this is my angle. And the distance here from the right in front of you, we'll call this distance here x. So this is the whole thing will be x as a function of t. And this right over here will be a given x. So everything's relative to this position here. So how far it is away from you, this way would be x, and that would be x as a function of t. So we can say that theta, the angle theta, or we can say the relationship here, we want to get this involved, is we've got a right triangle here, so we use right triangle trigonometry. And this angle is related by x and 180. And if we look at this using a right triangle, this looks like this is the opposite, and this is the adjacent, so that looks like that's tangent. So we can say the tangent of theta equals opposite x over 180. And we're going to be looking for, I should have written up over here, sorry about that, we're looking for d theta dt, and that's going to be in radians. And that's, first of all, when the car is right in front of you, so a, when x equals 0, because this is my position, this is my x value when x is 0, inside that right triangle is 0. And b, 1.5 seconds later. Now what would that be? Well, x would equal, now if I'm going at 220 feet per second, this is 0, after 1 second I'll be 220 feet, and after another half a second I'll be another 110 feet, because half of 220 is 110. So 220 plus 110 is 330 feet, so that at x equals 330 feet. Okay, so I think that makes sense because I'm going 220 feet per second. After 1 second I'd be at 220 feet, and after another half second it's another 110 feet, so my x position will be at 330 feet. So we want to see what theta is there. Okay, so let's first of all we're going to try to find d theta dt, so we're going to have to take a derivative, so it's a little bit easier, so we can solve this as to use arctangent. So we'll say theta, that's the angle whose tangent, so inverse tangent is of x over 180. All right? So if we take the derivative d theta dt, which is what we're looking for, this will be in radians. This is going to be 1 over 1 plus x squared. In this case, it's x over 180. X over 180 squared. And then this is a function, so we have to take the derivative of this. Well, the derivative of x over 180, that really is kind of like 1 over 180 times x. And the derivative of that would just be 1 over 180. And then we have to take the derivative of this, so that would be dx dt. Because if we take the derivative of this is going to be 1 over 180 times dx dt. All right. So there's a derivative, and then a, x is 0. So d theta dt will equal 1 over 1 plus, and that's going to be 0 over 180 squared times 1 over 180. And my dx dt was 220, so times 220. And this is all going to be in radians per second. Okay, well, this is just 0, so 1 plus 0 is 1, 1 over 1 is 1, so that's just going to be equals just 220 over 180. And that reduces to be 2 goes in 11 over 9. Radians per second. 2 goes into 22 11 times, 2 goes into 18 9 times, zeros go like that. Okay, now the B part is going to require a little bit more arithmetic. Everything's the same except not being 0 now, it's going to be 330. So now we have d theta dt equals 1 over 1 plus, and then we're going to have x, which is now 330 over 180 squared times, again, the 1 over 180 times the 220. And again, that's going to be radians per second. Okay, now we want to simplify this. Oh, man. See how much we can simplify this. This is going to be some arithmetic, isn't it? Like I said, I made these up pretty fast, okay? Well, the 0 over zeros go, and 3 goes into both these. So 3 goes into 33 11 times, so I got 11 over 6 squared. And then we already said that this reduced to be 11 over 9, so that's going to give us a little bit of relief there. Okay, and that's all going to be radians per second. So how do we deal with this? Well, not much to do there, is there? Not much I can do. Yeah. Just have to square it out. So I've got 1 over 1 plus, and then 11 squared is 121, and 6 squared is 36. And that's going to be times 11 over 9. Now I do have a complex fraction here, so I can fix this up real fast by multiplying the top and the bottom by the LCD, which is 36. So I'm going to do that. Still got the 11 over 9 over here, don't forget that, but we can fix this up. So now this is going to equal, and then I got 36 on the top. And this is going to be 36 times 1 is 36. And the 36 over 36 become 1, so I just plus 121. And again, the times 11 over 9. And that's going to be 36 over, and then this is going to be 157. All right. 6 plus 1 is 7. Yeah, 157. And that's going to be times the 11 over 9. And 9 goes into 36 4 times. I don't know if I can reduce this by, I don't know much what goes into 157. Doesn't look like 3 goes in there. It doesn't. So I'm going to just leave this at 4 times 11 is 44 over 157, and that'd be radians per second. So sometimes these don't work out real nice, so you have to do stuff like this. And there you go. Okay, so that's a little more challengingly. That's a little bit more challenging arithmetically. But I wanted to see one of those because they don't always work as nicely as the example I did in class. So there you go. Okay, so there's a bit of work. And hopefully that all makes sense.